Why should you care about, learn, and use Scheme? This is what I want to talk about in this video. The main thing is that Scheme is a very minimal and elegant language. It is a dialect of Lisp, of course, and it sticks to a small core and doesn't try to implement every feature on the planet. I think this quote is really characteristic and puts it in a very concise language. Programming languages should be designed not by piling feature on top of feature, but by removing the weaknesses and restrictions that make additional features appear necessary. And I think this is really what we see in a lot of more popular programming languages, JavaScript, Python, C++, this kind of stuff, is that exactly that this is happening. They're piling feature on top of feature, implementing every feature that could ever exist into the main language, because the language is conceived in such a way that it really restricts what you can implement on top of the language. So you have to put everything in the language itself. I think C++ may be the best example of this. I want to contrast Scheme with other Lisp dialects, and these are the ones I mentioned in the Why Lisp video as well. First of all, Common Lisp really also goes in the same direction of, well, we'll just implement everything in the language and we'll just put everything in there. Well, in some sense, at least. I mean, it's still Lisp and all. Don't get me wrong. Emacs Lisp is, of course, tied to Emacs itself, which really limits the language itself. I mean, you can script with Emacs, and I've done that, like on the server side. You can do that, but it's kind of always a hassle and really, not really that great. And then there's, of course, Clojure. And I mean, Clojure is also I think very elegant, but it is tied to the JVM, so the Java Virtual Machine, which is kind of, a big point in my opinion, because it makes it sometimes very slow. And it also kind of forces you into a certain sense of workflow, I would say, or not maybe workflow in a practical sense, but more about like how you think about the program and how you program, what you program, and so on and so forth. Another point is that Scheme is a Lisp 1. That means that it has one namespace for procedures, so functions and variables. And this is in contrast to Common Lisp and Emacs Lisp, which are what is called a Lisp 2. So they have two different namespaces for procedures and variables. Clojure, on the other hand, is Lisp 1 again, I think. So let me show you an example. Let me switch to my editor. So on the right, I have a Scheme file, or a text buffer, and this is Emacs, of course, and on the right I have a REPL. So if I want to define a function if I want to define a variable in Scheme, what I do is I call define, and then the variable name, let's call it ABC, and then, for example, some string, ABC string, or something. And if I now evaluate that, then the variable ABC is bound to this string. So if I, for example, enter it in the REPL will return ABC string, because that is what this variable is bound to. If I now want to define a function, I can use define again and define a function or a procedure, as they're called in Lisp normally. And now we can do the same thing. For example, we can again return ABC string. And if I now define this, it will redefine ABC. So if I now call ABC, it will not return ABC string, but it will rather return a procedure. And if I now call this procedure by enclosing it in parentheses, I get back the string ABC string. So I hope this example is clear. So this definition overrides this definition. Of course, if you first evaluate this, then this. And again, this is in contrast to, for example, Common Lisp or also Emacs Lisp, where you can't do that, where you have two different define keywords. So one for defining variables and the other for defining functions. And I think the way Scheme does it is way more elegant, and you can more easily pass procedures around. So you can, for example, more easily work with something like map or generally higher order functions. And you don't have to have like awkward syntax. So for example, I think Emacs Lisp, if I have this in mind correctly, has this syntax, so this hash quote symbol for getting the function of a symbol, if that makes sense, and only quote to get like the symbol itself. So yeah, so that's I think a big difference. All right, next up I want to talk about language specifications, and in particular, and you may have heard of this if you've heard of Scheme, is like the R5RS specification is only 50 pages long, wow, and all that. And if so go to the browser, and there's this website scheme.org, and this is kind of a hub for all things Scheme. And there's the standards page, and here you can see all the Scheme standards. And the newest one is R7RS. So these always stand for revised, then the number, then report on the algorithmic language scheme. And again, the fifth revision is only 50 pages long, as you can see here. And this is really a very elegant language design, you have to say. I mean, you can read through this in a pretty short period of time, and you can actually wrap your head around the whole language. And I think that's not really possible with other languages. I mean, try to understand everything of C++. I mean, yeah, that's probably not going to happen. The same with JavaScript or Python, because these languages are just so huge. And not with Scheme. Scheme is really minimal when it comes to the language specification itself. Which then leads me to the next point, which is that, of course, you can have a small core language, but you still want to have all the fancy features. Like you don't want to have to implement everything yourself from scratch every time. So there is a good extension standard, which is called the Scheme Requests for Implementation, or SORFI, I think they are pronounced. And again, scheme.org has a nice link to these extension standards or extension requests, and it lists out all the requests and with keywords and like dates and title and author and whatnot. And you can click on them. And for example, I have pulled up the first request for implementation, which is about a list library, because the R5RS specification doesn't really define it doesn't define list procedures. So, for example, we can read here, R5RS Scheme has an impoverished set of list processing utilities. So this is a way of extending the language, of extending the standard, but making this an optional thing, not having it in the core language. And if you then want to use this, you can just import this as you would import any other library or any other extension. So for example, import SORFI1. I always pronounce it as SRFI in my head, but yeah. So if I import that, it gives me back some import output, and now I can use these procedures. For example, I can use map or length, and these are not defined in the core language. Even though if you think of Scheme, you oftentimes think of, well, it has map and it has like fold and filter and all this kind of stuff, and car and CDR and whatnot. But these are not these are in the SORFI1. And what's nice about this extension standard is that now, because, and I will get to this in a second, there are lots of implementations of Scheme, and if they all conform to the standard, of course, you can use the normal library functions you're used to in every Scheme implementation. So you can be sure that, for example, length of ABC will give you back 3 in all implementations of Scheme which conform to the standard, which of course for SORFI1 most Scheme implementations do. Alright, so that's about standards. Next up I want to talk about implementations, because there are lots of good implementations for Scheme. And I've just listed out 4 here, but there are again lots of implementations, and if you go to scheme.org, you can also see down here, for example, all the implementations and which revised version of the Scheme language they implement. And you can click on them and learn more about them and this kind of stuff. So again, 4 of the most popular, I think, are Racket, chess scheme, Guile scheme, and chicken scheme. Racket is kind of, I feel like Racket is kind of its own thing. It's a scheme, but it's way more than that. And it's also very beginner friendly. Chess scheme is a project of the company Cisco, I think. And it's kind of termed like industrial, an industrial grade implementation of scheme because it's very, very fast. But it doesn't really have that great of a like community, doesn't have that many libraries and so on and so forth. Guile scheme is maybe the most popular scheme because it's the, well, I don't want to say official, but the de facto official scheme version of the GNU project. So many pieces of software of the GNU project are written in Guile or are extended in Guile. For example, one of the most popular is GNU Guix, so the functional package manager. And last but not least is chicken scheme. And this is the scheme I use for pretty much everything. And I have also used in this video and also in the WhyLisp video. And I will also make a video on why I think chicken scheme is the best scheme for practical purposes. Yeah, so I don't want to go into that too much here. But as I said, scheme is also easy, quote unquote, to implement yourself because the core is very minimal. And there are, I mean, if I switch back to this list of implementations, these are just like a few implementations which have like a substantial following, I would say. So which actually have more than a few people using them. But there are many scheme implementations. And again, you can implement it yourself because the core language is just so small, simple, and elegant. You just have to understand, of course, what you need to do to implement that. And last but not least, I want to say that scheme, it is often thought about as an academic language, as like the Latin of programming languages. And I think this is true for Lisp in general, but especially for scheme. It is thought as an academic language. Well, you should learn it, but well, not use it because whatever. And I want to say that scheme is a real life programming language. Like you can program everything in scheme that you can program in every other language. But of course, scheme and Lisp in general is not as popular as other languages like Python, JavaScript, this kind of stuff. And if you want to just kind of glue together your machine learning software as a service project, then well, yeah, then you should probably use JavaScript or Python or something like that. But if you want to like program simple programs that that compute stuff, then I think scheme is very, very good, and Lisp in general. So for example, what I have done, like my practical use case is web development, and I have written one of my use cases is web development, and I've written a static site generator in scheme, in chicken scheme, and I have also written a atomic CSS engine in chicken scheme, so a alternative to, for example, Tailwind or Uno CSS. And it's really great. I mean, it works great. It's a programming language. And I think this is really a point a lot of people kind of skim over. Because what's the point in learning a language if you don't actually want to use it? So that's it for why scheme. These, I think, were the main points that I wanted to touch on, which differentiate scheme from other Lisp dialects. I think scheme is, like, in a more general view, it is kind of the minimal and elegant member in the Lisp family, as I have stated in the beginning. And I think this is its main selling point. Well, selling point, in quotes. So yeah, that's it. Oh, another thing I wanted to mention is that there is a great introduction to scheme, I think, in the Chicken Scheme Wiki. So it talks about a few of the things I mentioned in this video and a few others. And I think it's just a small introduction here on the Getting Started page, but it's, I think, really good and gives you a great overview. It also goes in detail it also mentions the differences to other Lisp dialects, and which I've also done in this video. And yeah. So I will link this page and all the other pages I mentioned in this video on my website in the video section. And if you want to read any of them, you can find them there. All right. That's it. Have a nice day.